Good afternoon. Welcome to another episode of Let's Tackle Algorithms. Today we're looking at ugly number. Basically, we have to return whether or not a number is ugly, and we determine that to see if its prime numbers or its prime factors are 2, 3, and 5 or anything else. If it's anything else, then we return false. If it's only those, we return true. So what we're going to do first is we already know odd numbers wouldn't fit into that category. So if we do if sorry, I have a bad thumb today. If n modulo 2 does not equal 0, return false. What I'm going to do here is I'm going to allowances, so this is what we're allowing: 2, 3, 5. We're going to also create a variable here. Let ugly equal true. So we're going to assume something's ugly for now. Then we're going to start a for loop. So we're going to do a nested for loop for this. Let base equal 2. Base less than equal to n divided by 2, since we only need to go halfway for this. Then base plus plus. Then what we're going to do is for the multiplier equal to base less than or equal to and equal to, oh, not base, multiplier. Less than equal to n divided by 2, and then multiplier plus plus, and this is where we're going to start doing our logic. So if the base times the multiplier is equal to n, then we want to check. Actually, first let's just make sure this works. Base times multiplier equal n. Let's run that. True, true. Okay, so it is running into this. All right, and then what do we want to do here? Let's check if either of those are not in the allowances. So no. If allowances includes base equals false, or allowances includes multiplier equals false, we're going to set test false. At the end here, we are going to return ugly, not test, ugly. So if n divided by 2 is not equal to 0, okay. I believe this will work, because so what we're doing here is we're creating a number to multiply, and what we're multiplying it by, and then we're testing that multiplication. If it hits the number that we're testing, then we check to see if either of those numbers, the base or the multiplier, are not in our allowances array of 2, 3, and 5. Then we return false. All right. Let's see. Accepted. All right. Let's see if it'll accept it. All right. Let's get rid of the console log there. All right. Actually, first let's add some comments to this. X times y equals z. X or y does x times y equals z. Actually, all right, let's make sure that's still proper. Should, yeah, okay, submit. Come on, come on. Taking a long time. Wrong answer. 8. Why is that not working? I think it said something about 8. Given 8 times 2 times 2. Oh. Because you can multiply twice. Because you can multiply 2 to the third. I think what I would have to do there is check for the multiplier, check if the multiplier can be divided by 2 or divided by 2. That's a toughie. Normally I would just assume 2 times 4, but no, that you can do 2 times 2 times 2. How do I check to see? I don't know how I would do powers in this. I'm gonna check the commons. Okay. Oh, this one's commented. 0 negative. Okay. Initialize empty array for prime factors. Check if it's even. Iterate from 3 until square root of the number. Oh, interesting. Until square root of the number, because second maximum of a number is divisible is always less than or equal to square root of the number. Also push number if it is prime. Interesting. Then if num is greater than 2, prime factor dot push. Final condition to check if the array has anything greater than 5. So we need an array with 2, 3, or 5. Yeah, because 4 can be split into 2s. This is a little too spread out for me to be easily readable. Is ugly let primes equal 2, 3, 5. Ugly double bank num. Okay. Ugly equal primes dot sum. Primes. If okay, this is a little confusing for me. Oh, well, number is greater than 0. What? This is like 3 n to the third. So this is like 3 loops here. Interesting. I want to try this. I gotta try this. Oh, I forgot the bracket. Num is not defined. Oh, I need to change this. I could have just changed it up here, but whatever. Oh man, yeah. Wow, that worked. Alrighty then, yeah, I guess I would certainly do it. So you really just keep doing that. Interesting. I guess sometimes the simplest solution is the best. Alright, this has been Ugly Number. Thank you very much for watching. See you guys in the next one.